In this month's roundup of regenerative agriculture news, I'll begin with a story about new research that delves deep into root architecture. The researchers conducted studies on intact samples of both single species and diverse mixtures of cover crops to understand how root systems behave in their natural environment. Next, I'll discuss an article that explores the challenges of bringing microbial inoculants to the field. While these inoculants may work well in the lab, they often fail to deliver results in real-world agricultural settings. However, one team is making progress in understanding why this happens. Following that, I'll highlight some innovative approaches by farmers who are using plants as strip tillers and employing sheep as solar panel vegetation managers. To wrap up, I'll share a story about reimagining kochia, normally considered a weed, as animal feed that can thrive on your harshest land. Welcome to Plants Dig Soil, a podcast about realistic regen ag. I'm your host, Scott Gillespie, and I'm an agronomist from the Western Canadian prairies specializing in climate-smart agriculture. I discuss scientifically proven practices that benefit the planet and, just as importantly, farmers' economic sustainability. Be sure to visit my website, www.plantsdigsoil.com, for resources and information about the services that I offer. Have you ever heard of cover croppers talk of the advantage of diverse mixtures in soil exploration? They often emphasize how diverse mixtures explore more soil and create synergistic effects below the surface. This perspective differs from research studies that often recommend single species or simple mixtures. I've covered this before in episode 012, Simplicity in Cover Crop Mixes. A team of researchers set out to delve deeper into this topic. Root research presents unique challenges because the only way to observe roots is to dig them up. However, this disrupts their spatial location and interactions with other roots. To overcome this, the researchers collected intact bricks of soil and meticulously separated them to gain insights. They made two fascinating discoveries. First, when you pair a shallow rooting crop with a deep rooting crop, they tend to explore their respective soil layers effectively. For example, oilseed radish delves deep, while cereal rye thrives in the surface layers. However, when you consider the total root mass, there's little difference between a single species crop and mixture. In other words, planting just cereal rye results in a dense mat of surface roots, while planting only oilseed radish yields deeper roots. In a mixture, you get half the root mass of each. Instead of thick roots, you end up with thinner ones. This aligns with an energy balance perspective, as there's a limit to photosynthetic capacity above ground. When you blend two plants in equal proportions, it naturally reduces the root mass below. This insight might explain why a single species crops are preferred for specific goals, such as weed suppression. Feel free to share your thoughts and speculations on this topic with me by sending a message or commenting on social media, or through an audio message on Spotify or my website. Also, check out the full article in the show notes for more details. Moving on to microbial inoculants, here's a common scenario. A lab identifies a microbe that benefits a specific crop. It shows promising results in controlled lab environments, but disappointingly, it fails in field trials. So what's causing the discrepancy? One research team set out to unveil this mystery. They isolated microbial strains that individually benefited plants in lab tests. When they combined these microbes in sterile lab trials, the expected results didn't materialize. It appears that the mere presence of another microbe can hinder the desired response. This helps to explain why, as soon as a microbe that individually was good for the plant comes in contact with multiple native species, it dies or the plant doesn't want to make a deal with it. These findings, though disheartening for researchers, are valuable for future research. They shed light on the challenges of translating lab findings into real-world applications. As a result, I approach new products cautiously, as promising lab results don't always translate to field success. Now let's explore farmer-led innovations that address a common problem in areas where cover crops overwinter. Planting a cash crop the following spring can be a challenge due to the dense cover of a crop. Some opt for winter-killing crops, but this presents its own challenges, especially in wet springs, as they tend to hold the moisture in place and keep the ground cool. Farmers are combining these approaches by planting cover crops in strips. Winter-killing cover crops die off, allowing the planters to easily clear the residue and sow the seeds. Meanwhile, overwintering cover crops continue to pump out excess moisture, provide soil stability, and suppress weeds. If it happens to be a dry spring, they could be sprayed out early. They may still impact early season growth of cash crop by light interference, but it would be less than a plant emerging in a completely enclosed canopy. To conclude, I'd like to highlight a couple articles that challenge traditional farming models. In one, a farming couple decided to use sheep as vegetation managers for a solar farm instead of taking on more debt to buy grazing land. In this case, they actually get paid to graze. There are challenges. The sheep need to be concentrated so that they can take down all of the vegetation and get moved often. They also need water, but they also get shade from the solar panels. This innovative approach benefits both the energy industry and agriculture. Now finally, what do you think of when you think of kochia? A weed, an eyesore in a salty area of a field? Why not make animal feed out of it? Testing to know the salt content and other feed parameters can allow it to be integrated into rations or grazed directly. Now, I'm not an animal nutritionist, but Barry Yermako is. Check out his article and get a hold of him if you need help with crops once they get turned into animal feed. In my life as an agronomist, the big thing this week seemed to be responding to funding applications. There were 2 programs for this last year. One ran out of money early and one just got going. For practices that were implemented this year, the invoices need to be submitted to get the money back. It's about now that farmers are winding down from the year and getting things organized. I expect fall fertilizer to be starting next week, so I'm getting those plans in place. The most amount of my time was still spent preparing for and teaching my classes. Thank you for listening, and I'll talk to you again next week.